Alright, good afternoon everyone. I'm Dave and welcome back to my channel, or welcome if this is the first time you've popped your head in by. So I don't know about where you are, but the weather here in Cyprus has been absolutely terrible this last 3, 4, 5 weeks coming up now. We've had relentless wind, cloud and rain, and it's been extremely cold. Coldest it's been here for many years. It's been touching down to 2 degrees C in the observatory. And this is probably the coldest I've felt it since we moved here to Cyprus, and it's certainly, compared to this time last year, or even at the beginning of March last year, when we were into shorts and t-shirts weather, we ain't been anywhere near that this year, although we have had a couple of days when the wind's died off and the sun's come out, and that has certainly helped to some extent. But it's not helping at all when it comes to trying to do astrophotography, and it hasn't helped at all either when we've been trying to do solar imaging using my new Lunt scope. Again, we've only managed a few hours here and there before clouds have rolled back in and destroyed the day. But last night we did manage to get a few hours break, although the full moon is washing out the sky and not much good for broadband imaging. So I thought, well, I'll turn the RASA 11 onto the moon and see what we can get there. So this was the image I captured last night after a bit of cleanup, and it's probably one of the sharpest moon images I've taken so far. This was with the RASA 11 sitting in the observatory and using an ASI2600 one-shot colour camera. However, I did this fully remotely. I didn't go outside at all, but I had left an IDAS MBZ UHS 2-inch filter on the camera from previous playing around, but I couldn't be bothered to go out and remove it. So this is with a filter in there that probably shouldn't have been in there, but never mind, it came out not too bad. So anyway, enough of the ramblings. This is not why we're here today. Today we're going to talk about, or I'm going to introduce to you a project I've been working on over the last couple of weeks. While the weather's been horrendous, I've been making use of the rainy days and trying to solve another problem in the observatory. So I scratched off the dust off the keyboard and opened up Visual Studio for the first time in probably 10 years. Dusted off the C# programming and spent many hours of trawling and searching Stack Overflow and Google and the Microsoft documentation on what I was doing. But we've come up with a product to solve a problem that I've had. So let's take a look at it. Alright, so you may remember, if you've seen my previous videos, that in the top video I unboxed and installed a Unihedron Sky Quality Meter into the observatory. So this records the sky conditions and embeds that data into the imaging. So that was working great, and then obviously I acquired a second telescope, set up a second rig, and being a USB device, it's not obviously designed to communicate with two machines. So in the second video, the one at the bottom, I came across a piece of software called Serial to IP, and we installed that, and that allowed multiple devices to communicate with the USB device. Although it did work, it was not reliable and it kept dropping connections, it kept causing some other problems. So over the last few weeks, or the last couple of weeks, I've been writing a piece of software to perform this function, and so far so good. It appears to be doing exactly what it should. Alright, so here it is. This is my Unihedron USB Sky Quality Meter server. It's written in C#, and I released the first 2 builds of it yesterday. So this is the GitHub page. All the source code is available, and the application is available to download from the GitHub. Here on the right hand side of the releases page, we can see I've released both 64-bit and a 32-bit version. So this is fully self-contained. There's no requirement for any additional frameworks to be installed, but we'll come on to that in a minute. So let's head over to the observatory and take a look at the actual software which has been running in there for the last 24 hours or so. So here we are on laptop 1. Let me just move myself out of the way a bit. So here we are on laptop 1 in the observatory, and here we can see the server is actually running on the laptop, and in the background we can see I've got NINA connected through the serial SQM observing conditions ASCOM driver, which was provided by Dizzy Astronomy. So the application itself is running here and acting as a server for the USB device, and here we can see it also trends the data as it comes through. So each data point that comes in, we bang on another line onto the trend, and obviously we're during the day at the moment, so the sky is brightness, so that's why the NELM, which is a calculated number based off the average reading of the USB device. So that's why there's nothing showing here. But if we pause the trend scrolling, and we can go back and look at what was going on last night. So here we can see this is a typical night here, and obviously it's a bright moon, so we're all hovering around the 17 magnitudes per arc second squared, and the naked eye limiting magnitude is the green line. Was hovering around whatever that was, 5 last night. And we can see the temperature was also on the trend there, in the low 3 degrees, 4 degrees coming up through the night. Now what you've got to remember, of course, this is the temperature of the device, this is not the ambient temperature. But it does obviously give you an indication of how conditions are changing. Then as the morning starts to break, and we can see the sky brightness increases until which point it drops off the scale altogether, and the sun starts to rise and the temperature starts to rise outside on the device, and that's why it's topped out there at 30 degrees C before coming back down again as the sun's gone behind clouds or whatever's happened. So it just gives you a rough indication of what's been going on during the night. So what else can we do? Well, we're connected to the serial port that's attached to the USB device, and we're pulling from there every 10 seconds, and this is where we can see the latest response message coming back. So we've actually sent out a command, the UX, which is the unaveraged values, to the USB device, and this is the raw data that's come back. I actually do 2 successive commands, an RX and a UX, which is the averaged and unaveraged data, but the UX is always second, that's why you see it as the last response. And when we first connect to the USB device, or the SQM meter, it also goes and gets the data about the device. So it's running protocol 4, model version 3, feature version 76, and the serial number of the SQM meter. On the right hand side we can see I've got the server running, and it's set to listen for commands coming in on port 10,001, and you can see underneath that the last request received. So here we can see it flicking back and forth between 192.168.88.24 and also from the local host address 127.0.0.1. Now these are the 2 laptops in the observatory, so they're polling every couple of seconds. It's just the default that they're set for. I haven't seen a way of slowing that poll down, but it does show you that you've got clients coming in and they're requesting the RX message and the date time stamp of when that request came through. You can see at the bottom the green status indicators. So it's green's telling us the serials are connected here, and it blinks when there's a serial poll made to the USB device, and we've also got the green for the running status. And here we've got the server clients running, coming in, and how many clients are currently connected. Now this is one area that is an issue, but it doesn't seem to be affecting the software. Is under certain conditions, I'm still trying to pin it down why it doesn't disconnect, or the clients don't disconnect cleanly, or something goes on so it gives a false client count. It doesn't reset back to 0, as each connection should be closed automatically by the client once it's received the data. But there's something going on there, and occasionally we get these numbers which are sitting high, but when you stop the server it all resets back to 0, as all the outstanding requests are just considered gone. And then the number on the right hand side, we've got 4,320. Now this is actually the data store, so we do keep in memory a whole bunch of data, and then just cycle that once the current limit is reached, which is a definable limit, which we'll show in a minute. However, I'm not currently using that data store information for anything other than storing that data, and it can be looked back upon, but in the future I'm planning on rewriting the trend engine to actually go back and be able to pull data points off, so you can see exactly at what time the data was for any given part in the trend. But that's going to take a lot more work to come up with that trend engine. So what else can we do on the front screen? So we can click on serial pole and we can currently see the snapshot table. So this is the IX, the RX and the UX messages which the application supports, and they're the typical messages that are called by external client applications. And this is the raw data that's come back from the USB. So we can see here the IX information, which is coming back with the 4376 and the serial number, which ties in with the data here. And then we've got the average data, so we've sent the RX command, we've got the R response, and then the appropriate parameters for the various things, the magnitude, etc. So the magnitude, the frequency counts, some calibration data that we don't really interested in, and then the unit temperature. And then of course we've got the unaveraged data as well, which does closely follow the RX data. However, it does, depending on how quickly the ambient conditions have changed, you will see on the trend, let me just scroll back and see if it's visible. Yeah, you can see the red and blue are closely following each other. But occasionally it does take a slight drift off depending on what clouds have done, etc., or somebody's turned a light on and things like that. So the other thing we do is, based on the latest average, we calculate the Bortle class, and we also calculate the naked eye limiting magnitude, and also this white box here indicates the colour scale for that class. So that is based on the Wikipedia Bortle scale page. Here we can see how the classes are defined based on the approximate magnitude per arc second squared, or the limiting naked eye limiting magnitude for all the different Bortle numbers, and the colour classification down the right hand side, and there's the table for the Bortle numbers. So that's where that information is derived. Alright, so also along the bottom, if we click the memory number, we can actually pull up the memory store, and again we can turn off the auto scroll, and we can actually look back at any point in time and see what data is available in there. So the coldest the unit temperature got to last night was 3.8, which is obviously inside an enclosure, which is also being heated by the electronics, so that's an artificially high number. Alright, so setting up the application is very simple. So at the moment you can see that all the configuration menus are disabled. This is because the clients and the server is running and the USB is connected. So if I stop the server, we can now gain access to the server configuration, which is just a straightforward set the port number that you want clients to connect in on. If we disconnect the USB device, So we can go in and set the serial port and the interval at which you want to poll the USB device. Now the conditions don't change that often. I've actually got this turned up higher than it needs to be, although as I said at the beginning there, NINA seems to be polling every couple of seconds, which seems a bit excessive, whereas Astrophotography tool, its quickest poll rate is actually 1 minute. So it's up to yourself. It doesn't really change anything other than how frequently you're just basically making redundant data calls to the USB device. So what happens here obviously is once it pulls that data, it goes into the snapshot data. So if NINA or any other application just keeps polling frequently, it doesn't really matter, because all that's going to be sent back is exactly the same data they just got 2 seconds ago. So that's in the serial. In the logging menu, we can set how frequently we want to data log into memory. So the number of records to retain, again, this is the in memory, so you can either have no limit, in which case it just keeps polling constantly and just continually filling the memory. However, having a look at the diagnostics while building the application, we're storing around about 56 bytes of information every time a new data record is added, so it's not a huge excessive amount of data. So you could theoretically just keep going and going and going, and on modern machines it's highly unlikely that it would cause much of a problem. However, I wouldn't like to see it run indefinitely, so I have actually set the maximum upper limit when records are being set at 10,000 data points, or data records, which each record contains all the data, and the minimum again is down at 10 seconds. So once you've set the logging interval and you've set your maximum number of records that you want to retain, it will calculate the duration of how much data is going to be visible. So you typically might want to just store enough data for a daylight to day daybreak period, so maybe typically 12 or 15 hours or whatever, up to yourselves. But there is the option, should you choose, to just run it indefinitely. However, I wouldn't recommend that. Alright, so at the bottom of this section we've also got file logging. So we can also write all the log data out to a log file. The data is stored in a comma separated values, and it does include the units and the data point name, and you can store it to the default path, which is a folder called logs inside the application executable folder, or you can store it to a custom path which defaults to your desktop, and then a folder. I can't remember how I derived that name. I think it's the application folder at the moment. And then there's 2 buttons on the right hand side, so you've got quick easy access to get across to those folders and look at the data. Obviously I'm not currently logging, so there's no files there. So that is the logging, and the last setting is the trends in units. So again, we set the range of the trend. So in this instance we've got 0 to 30, and that covers all units, so you have to factor that in when you're looking at the temperature reading of the unit. However, I find that if we're running in degrees C, which is the units that come back from the SQM meter, then typically 0 to 25 or 0 to 30 is sufficient for typical night logging. And then down at the bottom we can also set the colours of the trend and enable by default which trends are being plotted on the screen. You can, once we're connected, turn these on and off, although it doesn't, as I say, go back and check the data and fill in any missing data points. So, and on the units for temperature, we can set either centigrade or Fahrenheit. By default it comes off the unit as centigrade, and obviously if you change it to Fahrenheit, it's going to change the value that's displayed on the trend, so you need to factor that into your range if you're concerned about that. However, it also only changes the data that's displayed along the top here of the trend where it says temperature. It does not store, it does not change any of the data in the back end, so in the log files or the server response, latest messages, or the data store. They're all the raw data. And then lastly, on the help screen, help menu, I've got links to the GitHub repository where all the information about the application, the source code, the help files, etc. Is all available. So clicking on that will open up a web browser to GitHub, and I've also got a link there to my website and to the YouTube channel. And then on the About page, it just gives you the current version information, and again another link across to the GitHub repository. Alright, so if we go across now to, I can close the latest serial messages, and here in NINA, so this is again on the laptop that's connected to the USB device. If I disconnect the weather and we connect into here, you can see I've just set the IP address and the port for this laptop, as obviously it's running on the same one as the server. So that'll connect in fine there. And if we go across to laptop number 2 in the observatory, and here we can see NINA's also running, and obviously it's got a different setting. It's got the IP address rather than the local host address of the laptop that's running the server, and obviously the port number, and it's pulling in the data as we could see on the other laptop. So that works brilliantly. There's been no problems with it since I first tested it. And Astrophotography tool also works with it. So if I quickly fire up APT on the remote laptop number 2, which doesn't have the doesn't have the USB device connected, and I open up the tools, APT settings, and go into T and Sky, set LE, set the IP address of the other laptop, which I think was 20, can't remember now. If I go into NINA and check that setting there, 23. So 23 and port 10001 and click OK. We should see, there we go, the information has already been pulled back to APT. So all good there. So we've now got 2 instances of NINA and one of APT running over both the network and locally on the laptop connected to the USB. Alright, so that is really the software. If we go across to GitHub now, here we can see on GitHub the initial release pages. So if we just go back to the front page of the repository, you can see it gives you a bit of an overview about the software, and you can go into the wiki pages and read more about how the software is working, how it's configured, everything that we've just talked about, all the information's there. How to install it, so there's no installation required. You simply download either the 32-bit or the 64-bit zip file from the releases page, which is on the front and the right hand side. Download either of those zip files to your machine, extract it to a folder where you want to run the server from, and just run the application, go into your configuration, set it up, and that's you off and running, and it will automatically create the default configuration file before you've set any settings in it. Alright, so then we've also got, if you do have any problems, obviously you can raise a ticket, Now, as I've been playing around with it and I found a few things that I don't like anymore, I've just put them on here just so as I've got a log of what things I want to look at. But if there's any issues, you can obviously raise a ticket, whether it's a feature request or a bug report, etc. If there's anything you want to discuss about the application, we have got the discussion section on GitHub, and as I mentioned, we've got the wiki there with all the information on the installation, the configuration, all the different forms, information, APT, NINA and Nightware's SQM reader, how it's all connected, setting up for the tool, and then there's a bit behind the scenes here which just gives you a basic overview of how the application's working, how the event system's being used, and how the various classes and the forms all talk to each other. But it's a very high level overview. There's obviously a lot more going on behind the scenes with various other classes and temporary objects and things like that. So that's it. That's the UniUSBSQMServer, all yours on GitHub. Anybody who's using a USBSQM meter, feel free to enjoy, and obviously leave any concerns, problems, raise an issues, ticket, any ideas, suggestions, all that can be done through GitHub. So on that note, thanks for watching, thanks for listening, and wish you clear skies, and we'll see you again in a future video. Have a nice day.